Okay, hi everyone. Can everyone hear me all right? Yes, cool. Um, so, before I start my talk, I want to do a short disclaimer because I changed the title a bit. So the reason why I changed the title is because I think it was called Data Processing at Spotify using Scio, but that's too long to fit on my slide. So yeah, so I had to change it. So it's now called Scio Spotify, which is honest, I guess. Um, Also, another disclaimer. Yesterday, I went with Marco, who's giving a talk at 3 p.m. today, to have a beer after the conference. And we go there, and then we go out early because he says to me, well, I'm sorry, I can't stay with you because I wish to work on my slide a bit more. To which I said, well, I feel pretty good right now because everything is ready in my slides, right? Like one does. Except one thing I didn't like in my slides. I usually like to have a bit of a story to tell so that the thing is, just not boring, a bit entertaining and have a bit of fun, hopefully. And yeah, so I didn't have a story for this time. But I guess beer helped a bit. So I go back to my room in my hotel and then I'm like, yes, I know. I have the best story in the world. Mine. That's me. Yes. So the talk is now called Scio Spotify, a tale of an engineer's imposter syndrome and naive optimism, which I realize now is longer than the original title. Anyway, so let's get started with the main subject. Please do work. No? Oh, that's fine. Oh, Brock? What are you doing? Come on. I think, yes. Yes, so me. I'm an engineer. I've been working with Scala for like 8 or 9 years. I don't really remember, honestly. I contribute to open source projects, and about a year ago, almost exactly a year ago actually, I moved from Paris to Stockholm, Sweden, to work at that company called Spotify that you may have heard of. Hopefully, does anyone not know what Spotify is? Really? You? Boo! No, that's okay. So Spotify is a music streaming service. That's a very simple thing. So anyway, I moved to Sweden to work with Spotify as a data engineer in a squad, as we call teams at Spotify, called the FlatMap squad. So it shouldn't be a surprise that that squad is using Scala quite a bit. So anyway, that's never working. A bit about Spotify. Spotify has roughly, at least that's what the last public number says, we have 207 million monthly active users. So that means that for a given period of 30 days, on average, Spotify will see 207 million different people use the service at least once. We have roughly 100 million subscribers, 40 million songs, 3 million playlists. Well, I guess the point is we have data, and that's good because I'm a data engineer. And yeah, so at Spotify we use Scala for one thing only, and that's data engineering. So that's like a big thing. Ooh, yes. Thank you. USB, you have to try 3 times. Yes, thanks. Anyway, so we use Scala for data engineering. Given that Spotify is very much a data-driven company, that's a big thing. And recently, we joined the Scala Center Advisory Board because we use Scala quite a lot. So we thought, like, maybe we can contribute back. That would make sense. And given that Spotify has basically absolutely every business in the world uses open source, we thought that maybe, unlike all the businesses in the world, basically we can contribute back to. So we're doing open source, which I like. Where am I? Yes. Okay. Let's talk about the project that Spotify hired me to work on. So I'm working on this project called Scio. Who knows about Scio? Ooh, not everyone. Good. So Scio is a Scala API for data processing. So on the right side of the slide, you can see how it looks. That's the word count. If you write Spark code, that shouldn't be unfamiliar. It looks more or less the same. Anyway, it does batch and streaming. It's open source. It's on GitHub. And it's based on something called Apache Beam, which is a Java library that runs on Dataflow, Spark, Flink, and a number of other things. So Scio can do that too. So let's talk about why Spotify chose to develop Scio when we could have used the Java thing. Why would you go in all the trouble of creating a new project and maintaining it and all that things when you could just use the thing that exists, right? Why would you do that? That's stupid. Well, there's a bunch of things that we want. And I guess those are like the main qualities. We want good documentation. Quite a lot of people are using Scio, so we don't want them to call us and ask us like, how do I use this and that? But that's something that Beam gives you. You have decent documentation. We want something that is predictable, so like when it works, basically. That also Beam gives you. We want something that's fast, Beam sort of gives to you. And more importantly, we want something that's predictive and type safe. Of course, it's very obvious why we want something that's predictive. The type safety part sort of comes with productivity because when you write a batch pipeline that is going to run on hundreds of machines, processing terabytes of data, what happens is that it takes some time to run it, potentially hours. So if something is wrong with your code, you want to know it before, because running is expensive and the engineers are just waiting. So when you write new code, you want to have feedback as fast as you can. And well, it happens that the fastest feedback that you can get is the compiler, which tells you, oh, that's a mistake. You broke something. That's why we use Scala, because Scala gives you basically the last 2 points if you use it properly, compared to Java, which doesn't. Yes, so I have to do the magic thing. Anyway, so at Spotify, we have internally about 300 people using Scio. And those people are, and Scala. Those people are data engineers, obviously, but also data scientists and backend engineer. And that's an important thing to remember. We have like thousands of unique jobs. I don't know the exact numbers. That's too many. And we use it for batch and streaming. No, broke everything. Also, Spotify, late 2017, was ingesting roughly 200 terabytes of logs every day. So that was more than a year ago. So that was the last public number that I could find. So I would assume that now it's more. But that's, I mean, some data. I should mention something. When I joined Spotify 1 year ago, I joined it as data engineer, but I've never been a data engineer in my life at that point. And I didn't even had written a single data pipeline in my life, or let alone at the scale of Spotify. So that was interesting. Come on. And well, that's where the imposter syndrome kicks in, right? So, I mean, I've never done that in my life. I'm going to work on an open source framework that's used by hundreds of people in one of the most famous companies in the world that has a lot of data and runs thousands of jobs on it. Yes, sure. I mean, I do know a bit about Scala, but I mean, that's something different, right? So I was tiny bit scared, especially moving in a different country doing that. Yeah, so I want to talk about what happened when I did my first PR at Spotify on Scio. So back a year ago, I started working at Spotify, and of course I did. I started reading about Scio, And I asked one of my coworkers, who happens to be based in New York, well, what do you think I should work on? I mean, do you have a good first issue I could fix? Something not too hard. I could learn about Scio, how it's working. I've never used it. So, I mean, give something to me. And he's like, well, yeah, you know, I have an idea. There's like this pull request that someone started, another Spotifyer, some time ago. But it didn't progress in the last few weeks. And that thing is interesting. So maybe you could like take over that thing, work on it, finish it, and hopefully like submit your first PR soon. So I'm like, oh yeah, that's a good plan. Taking over someone else's job, finishing the thing, and hopefully in like 4 or 5 days have like my first PR at Spotify. So as a great philosopher once said, how hard can that be, right? I mean, easy peasy. So yeah, so I do my first PR, except it took me a month, so more like 4 weeks. And in the end, I had modified 36 files, added like 1,200 lines of code, deleted just shy of 600, 54 commits. Ooh. And yeah, and there was quite a lot of comments on it. Interesting. But then I remember when I submitted my PR, like, oh yes, by the way, 300 users, hundreds of terabytes every day, thousands of jobs. Yes, cool. I mean, this is fine. That's my first days in the job. I moved to different countries. I have no idea what I'm doing. And what could possibly go wrong, right? And it turned out, surprisingly, nothing. Everything was fine. Why? Seriously, why? How can that happen? Well, 2 things. First of all, types. Because, well, Scala tells you when you broke something, so that's good. And the other thing is, like, my coworker fixed everything. So basically, people know that what they're doing. Cool. So yeah, so I do that. And I'm pretty happy with what I'm doing. And then, suddenly, sorry, looking at the time. My manager comes to me and he says, well, you know, one thing you could do is like, there's that other squad that you're not working with. And they want to migrate a pipeline that's been written in Crunch on Hadoop, and they want to migrate it to Scio. Easy, right? I mean, you're the Scio expert. You've been working there for months. Ha! Yes. And of course, at that time, still haven't written a single data pipeline in my life. So I said, yes, of course. Why not? I mean, yeah. So the pipeline in question is actually fairly simple. It's just like, you know, something trivial. It just takes events that are incoming events, take a few private keys from users, join the two, and encrypt the user data, because, you know, there's something called the GDPR. So, fine. You could write a pipeline that looks like this. Easy peasy, 5 lines of code. What do they need? Why would they need my help to do this? So if you want to learn more about this, there's actually a blog post that you can read. But the thing is, again, how hard can it be? Well, it's Spotify. So the pipeline in question for one single type of event have to handle more than tens of terabytes of events for a single hour. That's billions of events. That's actual big data. And we have hundreds of millions of users, which mean we have hundreds of millions of keys. So the join between the two is big, pretty big. And it happens to be big not only on IOs, because you're shuffling everything, but also you're encrypting data, so it costs CPU. So that job was expensive to run with Spotify. And again, well, what happened? Well, it went well, surprisingly. So we rewrite the entire thing in like 3 weeks. It goes into production. It works. And what we did is, like, one of my coworkers, like, luckily someone knew what they were doing, came up with this idea, like, we can actually have like a a smarter join strategy. And basically, the main idea, I don't want to go into the details, but we had different types of join, and each one is handling a part of the data. And then at some point, we just fall back to the slow thing that works every time. One other thing you can look up is Sparky. So Sparky is another open source project by Spotify. That's a key value store that you can run in memory, but off heap on the JVM. And in Spotify, we use that quite often when we want to do a join that's too big to fit in memory purely, but off heap, that works. But also, we don't want to shuffle the data. So like sort of not big data yet, but not really small data so that it could fit in memory. Then you can use Sparky and join using Sparky, and that's pretty fast. Anyway, we write the thing, and boom, 50% cheaper than the previous version because of the optimization. And those optimization, of course, we could do, not because we are super smart, but because Scio being easier to use than Crunch, it took less code, was more type safe, so we could do more. And that was not dangerous. Like, we felt pretty safe about what we were doing. Good. Next, what happened? So I worked 3 weeks, and what could I possibly do next? Well, break everything, of course. That's what you do. I was very confident. Been working them for 2 months. Easy. Anyway, so we started working on the current version of Scio, called Scio 07. It came after the 06, obviously. Anyway, and it was a big one because we decided that we would break things for the first time. So your pipeline that used to compile would not compile anymore when you upgrade to Scio. So it was a bunch of things, including my very first PR. But anyway, we used that thing called the static coders. So, no. What coders are is a way to serialize the data. So in Beam terms, when you want to move your data between workers, which in a distributed framework you do all the time, you need to make that an array of bytes, send the array of bytes over the network, and once you've done that, you deserialize the data and you get like an instance of your class, right? And the thing is, what Scio was doing at the time was the same thing as Spark, I believe, is still doing, and I think Flink does more or less the same thing, which was we were using a library called Cryo. And what Cryo is a Java library that does everything runtime, like a Java library. So, cool. Only problem is, first of all, it doesn't really work out of the box with Scala. You have to use another project by Twitter called Chill. But also, because everything is runtime, it's pretty hard to test. It's pretty hard to, it's not exactly predictable, like sometimes it fails for no reason. The performance could possibly be improved, although I mean Spark is using it, so maybe it's fast. And what we wanted to go for is automatic derivation at compile time. So the point is, we don't want our users to have to write hundreds of lines of stupid serialization logic that they will get wrong anyway. But we still want something that's type safe, so static, pretty fast, and yeah, doesn't require a lot of boilerplate. So yeah, magic compile time thing. And in the case we can't do that compile time, we would still fall back to Cryo, because when you have a Java class, what do? You use a Java thing. So anyway, do this. Come on. And it changed Scio quite profoundly again. And basically every single method in Scio that used to require a class tag because something was happening in runtime now require explicitly that you pass a coder, so a way to serialize the data, right? And of course, when you do that, yeah, don't care. You break everything, yay! The user was super happy with this because the signature of the function actually changed. So when you upgrade it to Scio 07, your pipeline would not compile, and you would have like hundreds of compilation errors. We did a bit of work to make it easier. Most notably, there's Scala fix rules, so it sort of migrates automatically, but not completely, so it still breaks things. So the question that you should raise is, why? Are you sure that's a good idea? Like breaking the code of thousands of pipelines to Spotify, impacting hundreds of engineers. that's potentially costing a massive amount of money. And that's not good for business, right? Losing money. Why would you do that? Also, pain in the ass for like 6 months for us. Well, the thing is, like, when you do that, we saw this. Now, actual, like, real pipeline running in production. Thing gets 25% less expensive because serialization, when you're sending things over the wire all the time, is important. So yeah, I guess that's one of the takeaways of this talk. Serialization is important. It's not magic. You should care about it. If you use Spark, look into what it's doing, because maybe you need to optimize that. The pipeline would run faster. It would use less workers. It would use less CPU, less memory, and shuffle less data, which is good. So I was feeling good. Pretty great even. Anyway, that leads us to the next version of Scio, because we broke everything in 007, so why not do it again? That was great. No, I'm kidding. It's actually not breaking everything. But anyway, the thing is, like, when we started working on Scio 07, we had some ideas about where we wanted to go. And while Scio 07 by itself was good, because it was making things cheaper and faster, we had another idea. We knew that we were going somewhere, and that somewhere was Scio 08. So what we wanted to do was supporting something called schema coders. So schema coders, as the name suggests, is a coder with a schema. Great. So basically the point is, a normal coder is basically a pair of function. One goes from your type, or your instance of a type, to bytes, and the other goes the other way around, right? But it doesn't know about the actual data that's in there. It doesn't know what it is. A schema coder knows that it's serialized data, but also it knows how that data looks. It knows that there is something called username, and that's a string, and then there's something called age, and that's an integer. It knows that kind of things. And you can leverage that to a lot of things, to do a lot of things. One of the things you can do is support Beam SQL. So Beam SQL is basically the same thing as Spark SQL. That is, you write SQL, and that thing is actually more or less a function in the end, and you can run that on your data, and you write a pipeline using SQL as an external embedded language, sort of. But you don't need a database or anything, it's just your pipeline running. We can do another bunch of nice things, like converting between types, support Java classes, suddenly. Yeah, we wanted to do like a bunch of other small improvements in Scio API. So anyway, let's talk about Beam SQL. So basically, it would look something like this. So yeah, one thing is that's not a final API. We're still working on it, so it may change. It probably will change. But I want you to have the gist of what Scio is going to be able to do. So say you have an S collection. That's, in Scio language, a distributed collection. So your data on your cluster. And you want to do something simple with it. You want to use that S collection of users, and you want to extract the username and the emails as a pair of string and list of string. So you could do two things. You could do one thing with Scio. You could just map over it and write a simple function that does that. Or you could use a new SQL API. And basically what that's going to do is, or rather the reason why we want to support this is because, as I mentioned at the beginning of the talk, we are working with data scientists. And data scientists, they are good with math. Generally, they are decent with Python. They are really good with SQL. They know nothing about Scala. So when you tell them, well, you want to write a pipeline, that's cool. You need to use Scala and SBT, and then you deploy it with a bunch of stuff. That's complex. So wouldn't it be nice if they could write SQL, which they know already? It would, which is why we want this. No, there's a bit of a problem with this, and that's it. This thing over there. Because suddenly, instead of writing code, you have a string in the middle of your program, and that string is not just like a value that you're going to store somewhere or show to your users or something. It's actually doing something. who knows what. I mean, anyway, so it's complete magic. And again, it happens at runtime, which we don't really like. Yeah, I want that. So, I mean, when you use Scala, because you want to have a strong type system, and you want to have static guarantees about what your program is doing, doing this is suddenly Python world. You're sliding in that realm of uncertainty, and who knows what this thing is doing, and what happens when I refactor my program, which is thousands of lines of code. Will this still work? How do I write tests for this thing? Do I have even tests? Or is it going to fail after running for 4 hours on my 100 of workers cluster? I don't want that. I don't like that. It completely defeats the purpose of using Scala. So what do? Well, we try to overcome the fact that when the compiler sees your code, the only choice it has is to trust you. Like, oh, you tell me that thing is returning a pair of string and list of string. Okay. Yeah, cool. I have no idea what's going on, but if you say so, why not? We don't want that. We want the compiler to actually know what's going on. So given that you write this, a million things could happen. Like the query might not be valid SQL. Maybe the field that you're using actually don't exist. Maybe that type are not what you expect. That didn't even work. Who knows? Anyway, so we do this. Boom. So Scio has this function that for now is called tsql. It's probably going to be called something else. But what that does is, next slide. So your code becomes this. Is that it actually leverage the fact that when you use SQL in a pipeline, what it's doing is that it parses that string and make that a function, basically. And that thing happens to be a pure function, right? You don't need to read data somewhere. You don't need to do anything. Just like run the SQL parser, whatever is in Beam. Run that thing, gives you a function. You can run it. Great. And given that it doesn't do side effects, you can run it compile time. That's fine. But when you look at this, the compiler needs to know a bunch of stuff about your data. It needs to know how the input looks like, because of course the result of your SQL query depends on the input, on what you're actually reading. And also it needs to figure out what that query actually does and what it returns. And it needs to make sure that what it returns is actually what you expect it to return. So here we're saying, I want that thing to return a string and a list of string. The compiler needs to make sure that the query actually does that. I'm going to drink a bit of water. You have to wait for me. That's great. Anyway, so you write this, and say I have this in my code, in my pipeline, and can you see what's wrong? It's not easy, right? Even though there's like 2 lines of code, it takes you a few seconds. Yes. All the engineers like, it took you 30 seconds to figure out what's wrong in 2 lines of code. Just saying. Anyway, don't trust engineers. Yeah, that's wrong. That's never work. And when you do that, and you use this in Scio, the compiler, I insist the compiler will tell you, that's not SQL, you're an idiot. So you don't need to run the thing. That's good. Then, what happened if you do this? What's wrong with this? Well, name doesn't exist. I'm telling you because there's no way you can know. So anyway, you try to write that SQL query, and the compiler tells you, no, that doesn't work. Your data look like this, the thing on the top. It has username, which is a string, cannot be null, and emails, which is an array of string, cannot be null either. And what you expect the query to return is a string and an array of string. But the important thing is that column name, can I? Yes, here, the column doesn't exist. It tells you that. I can't find that thing. And again, that happened compile time. You don't run the query. There's no need to do that. What if you do this? You say, I'm selecting username and emails, and I expect it to be an integer and a list of string. Of course, that's never going to work because username is a string, not an int. And the compiler tells you this, and that's my favorite. There, It inferred the result of running that query. Tells you that thing, return username, which is a string, and emails, which is a string, an array of strings. And you said, I want an integer and a string. That's not going to work. You need to work that. Again, compile time, great. Okay, so that's all I have for Beam SQL. And suddenly, the thing that I want you to see is that we gain back type safety from SQL. That's pretty great. That thing actually depends on the fact that you can derive the schema automatically of your data, because the SQL query, as you can see, doesn't use Scala types, it uses SQL types. That's done with Magnolia. Yay, super cool project. And that's like, yay, hey John. And I think it took me roughly 200 lines of code to implement the entire thing. Anyway, easy peasy. The other thing you can do, given that you have schemas, is automatic type conversions. That's perhaps the thing that people at Spotify will like the most. So basically, given an S collection of A, an S collection of B, the compiler can figure out a way to convert A to B. It works for case classes. It works for Java beans. So if you have a Java bean, you want to convert it to a case class, you can do that. It works for case classes, between case classes, and it works with Avro records. And that, like, I know that people at Spotify will love me for this because they have to write boilerplate right now. We use Java classes for Avro, and then we have to turn that into Scala case class that have options and all the niceties of Scala, and that's boilerplate. So, say that you make a mistake. It's not possible to convert A to B. Boom. That happens. The compiler tells you, well, A looks like this, and B looks like this. That doesn't work. By the way, this thing actually uses the names. So it expects I, say you want to convert I, to exist in B and have the same type. The order doesn't really matter. It's by name. Anyway, I'm arriving to the end of my talk, so we're going to have lunch on time. Great. You can thank me later. The conclusion is going to be very short. So serialization is extremely important. You should look at it in your pipeline. I think as engineers, you don't really want to do this because, let's face it, it's boring, it's really hard, make a mistake, hard to debug. But if you really have big data and you have a pipeline that processes terabytes of data every hour, you can save a lot of money just by making serialization faster. By the way, that pipeline that I worked on that does encryption, we did before 07. So just last week, we realized that it was not using the newcoder thing. So we're like, can we use the newcoder thing? Yes, we can. We try it. And what happened is, like, for the biggest data sets, it makes the pipeline twice as fast. So yes, because it was using Cryo to serialize Avro records. And that's super inefficient. Cryo suck at doing this. So you need to write coder for this. And you know, Scio does it for you, so great. The other thing is type safety solve everything. I mean, you have a problem in Scala, throw types. It's going to solve it. You don't have to think about it. Types, just types. The other thing is Swedish is a weird language. Yeah. And next, optimism actually works. So be optimistic about your capacity of doing things because, you know, it works. Proof. Anyway, that's all I have. Thank you for listening to me. Does anyone have questions? John.
Thanks for talking, Julien. The example of Beam SQL, I noticed you explicitly typed the return type.
Yes.
Did you look at the possibility of having that inferred from the...
Yes.
Okay.
So we could do that, indeed. The thing is, as my coworker Gleb pointed out to me, don't do that. And the reason why is, you don't mess with Gleb, he's Russian and... Anyway, so very serious about what he's saying. But anyway, he said, if you use that, then you break IDEs. Because IntelliJ, when you use micro to create a type, it doesn't really work. So you're better off typing the thing and checking that what you inferred actually is the same thing.
So hello, I wanted to ask how hard is this typed SQL tied to SBT, and is it possible to use Scio with other build tool?
As far as I know, so honestly at Spotify, I think pretty much everyone is using SBT. I do know that one team is using Bazel to build their Scio pipeline. Nothing prevents you from using anything, basically. You need to make sure that it supports macros, but that would be it. Yeah.
Hi, thank you for your speech. Actually, I have two questions. The first one, have you implemented query optimizer for T-SQL?
That's a good question. That's a very good question. That's one of the benefits of using SQL. Obviously in Spark they do it because you know what the program is actually doing. It's not just like a black box function. You can try to optimize it. As far as I know, so we just delegate it to Beam. We don't do anything in Scio. Like literally you just call Beam and Beam
just
does.
type checking, yeah?
Yes. And as far as I know, for now, Beam doesn't optimize anything, although there's everything in place to do it. So it's only a matter of time.
Okay, and the second one is more common. Can you explain in few words how your development process with Scio works? As you said, you have around thousands of jobs. It's one large monorepo, or you spread the job across the teams?
That's an ongoing debate
and
at
how
Spotify.
To deploy? Yeah.
Yes, so that's an ongoing debate at Spotify. It's really a vast subject. You can go on the Spotify technical blog. We talk about what we're doing. But long story short, we don't have a monorepo yet. That may happen at some point. And Scio lives on GitHub because it's open source, so it's kind of like disconnected of that.
Hi, thank you for the talk. I'm actually familiar with other project I had before Scio. It's called Luigi. Is it still in production?
Which one?
Luigi. Which was
Luigi,
more
yes,
Python-based.
very much. So Luigi is the orchestrating framework that Spotify use. It's written in Python, and yes, it's very much still in production.
Okay, so do you combine them, or do you share for taking part for orchestration as well?
So yeah, so it's kind of the same question. Anyway, yeah, so Spotify basically use a bunch of projects, and I think pretty much all of them are open source, so you can check out GitHub. But basically we have Sticks, which is a scheduler, so it just like say that job has to run every hour and make sure it does. We have Hadis, which handles persistence of data, make sure that we don't have corrupted data because we're running the same job twice for the same time. And we use Luigi, which makes sure orchestrate jobs. So that job goes before this one because they depend on each other, that kind of thing. And yeah, everything is open source, so go check it out.
But you don't use Scio for orchestration?
No, Scio is purely a library for writing your pipelines.
Okay.
We used to have a Scala library that we tried to use to replace Scio, but it didn't catch up, so we killed it.
Okay, thanks.
Hi, thank you for your talk. It's just mostly information and shameless plug. There is a Creo macros project I used to develop that actually generates Creo macros for your Scala types, basically. So
yeah. Well, one of the things I should point to, though, sorry, rebound on your thing, is that the primary square is not only the time it takes to serialize data, that's actually like the least of your issue. The bigger one is the size of the serialized data is much bigger than if you write the pipeline, the serialization yourself. So that's why you use more memory and why you use more IOs, just because serialized data is much, much bigger than if you write the serialization yourself.
So, thanks for your talk. And you've talked that at transition to 0.7, you break everything. But the question is why? It seems that before it was a CNAS stack. Nobody explicitly passes a CNAS stack. So one obvious way was why not to derive the Z coders? Was there some obstacles of like deriving every coder and just doing some import with it implicit, and everything is working as before?
Yes. So there's a bunch of things. The first one is you can't derive everything. Like we derive, I believe, 95% of the coders, but if you use a Java class, say Java util local, you can't derive the coder for that. It's completely opaque to the Scala compiler. So you need a way to use that. The other thing is, when I say we break everything, we actually made it fairly easy to fix everything because Scala fix will fix probably 99% of your issues. So in the end, you will have like maybe instead of 300 or 1,000 compilation error, you will have like 5. So that's quite easy actually to migrate. And the last thing is, even if you derive everything, when you have a generic function that takes some type parameter and that needs to be serialized, deriving is not the solution. You still need to change the signature of your function to go from class path to coder. So that breaks. And ScalaFix can't do that yet.
Okay, thank you.
Hi, do you have any plans to overcome some of restrictions of Beam SQL? For example, it fails to handle, for example, in causes with many params, I think more than 19 or something like that, or for example, horrible like statement that fails with null pointer exceptions.
Yes. So Beam SQL is still, I mean, it works right now, but it works in a limited way. It's very much a work in progress at Google, and they have far more resources than us. We do have an engineer that's actually a committer on Beam that fixes a lot of stuff on Beam SQL because he uses it himself at Spotify, so he knows what's broken. But anyway, yeah, I know that Google is working a lot on that. They have like a lot of engineers fixing things, so I mean, it's only a matter of time before everything works.
Thank you. We will wait for it.
Hi, thanks for your talk and for great framework. I have a question about derived codecs. Google Dataflow supports updating jobs, but this operation may fail if coders are not compatible.
Yes.
Are derived codecs in Scio 0.7 compatible?
Yes. That would indeed break things if you have a streaming job. In batch job, obviously, you don't have that issue because you stop everything and you start everything. But yes, in a streaming job, you could hit that issue. And in that case, you can actually override what Scio is doing and say to it, use Cryo everywhere. So it doesn't actually change what it used to do. And that, in that case, not breaking everything.
Thanks. And another question about long-running streaming jobs. Have you issued some problems when the job ran fine for months or two, and then it stopped with processing stack or something like that?
Yes. So that's one of the things. Like Scio and Beam do support batch and streaming, but stream jobs are pretty specific, and they work in a very different way than batch jobs. And obviously, there's a question of what happens if the job fails for some reason. Then what do you do? And that's we had very much that issue at Spotify a few months ago, where I think the data in the input of the job got corrupted, and the job would just retry again and again and again and again and never stops. And yeah, there's no easy solution, I think, to that issue, sadly. I mean, you just have to handle it manually, have alerting, and someone takes care of it.
Thank you.
Thank you for the talk. The question is, do you use any runtimes for Scio apart of Google Dataflow?
Any what?
A part of Google Dataflow.
Yeah,
For example, Flink or Spark.
Oh, so at Spotify, no. Not that I know of. I mean, it could be. But I don't think so. We did try to run it on Flink because people in the community were asking about it. the main issue, like it works, the main issue is that you have a conflicting dependencies issue because Flink and Spark work by creating a fat jar where everything lives. So your dependencies actually conflicts with Spark or Flink's dependency, and that's the biggest issue. If you overcome this, one way or another, then you should be fine.
Thank you. And one more question. Do you heavily use stateful streaming processing?
Oh, that's a good question. Maybe? I don't know. I don't write. I've never worked on streaming myself with Spotify, so I know we have quite a few streaming jobs, but I don't know them enough to tell you that.
Thanks.
Are we good? Yes. Thank you very much.